Okay, cool stuff. All right, so ladies and gentlemen, if you remember when we were talking about angles, and hopefully one part when we looked at, we were going through any kind of angle, right? And especially when we started talking about the angles on the unit circle. We were talking about this angle on the unit circle, but there's one especially important thing that I talked about when we were trying to evaluate for the sine and cosine. The important thing we had to deal with is, remember, we have an angle, right? And then we're dealing with another one. And remember, it was rotated about a vertex. Well, when we created a triangle, remember, our angle created something special, which we call a central angle. All right? And that was the angle that we are going to use to help us evaluate our sine and our cosine. Okay, Yusuf? So what I did was I looked at theta, and I said, all right, here was my coordinate point, where here represented my y, and here represented my x coordinate. But it was always in concern with our central angle. And remember, our central angle is always going to be our angle that is going to be about with our vertex, or our center of our circle. That is going to be our central angle. Because if we were talking about an angle that maybe went all the way around here, we weren't concerned about creating a triangle. We were concerned about creating the triangle that was dealing with our central angle and this x-axis. All right? So let's go and take a look. If we can remember, when we have a triangle with that central angle, that created an angle that we could deal with, that we could find. If I know that this is so if I say find the sine of theta, right? Remember from the unit circle, we said that sine of theta was y over 1. Right? Because really it was opposite over our adjacent. But we just said it really just dealt with 1. So why is it y over 1? Well, let's go back and remember a couple parts. Let's go over our certain triangle, which we have our SOHCAHTOA we could go back through. So let's say in general, ladies and gentlemen, I give you an angle, or I just write you a triangle that has, my angle is theta. Now this could be on the unit circle, or it could not be on the unit circle. The unit circle always had a radius of 1, right? So your hypotenuse was always 1. But now what we're going to do is we're going to actually work on some problems that don't necessarily have a hypotenuse of 1. All right, so we're going to get out of the unit circle a little bit to just kind of practice now what happens when we have angles that are not on the unit, on the unit circle. So first of all, if you guys have your theta, the first thing we need to remember is what are trigonometric functions. So remember, here's theta, then here's going to be the opposite side. It's always going to be opposite of your angle, and here's going to be your adjacent side, where your adjacent side always connects your theta with your right angle, and your hypotenuse is always directly across from your 90-degree angle. All right? So if I say what is the sine of theta, you're going to say it's going to be the opposite over the, not adjacent, hypotenuse. And the cosine of theta is going to be the adjacent over hypotenuse. Because, ladies and gentlemen, now we don't know, Lauren, what the hypotenuse is. So we can't just say it's the opposite, which was y, or it was the adjacent, which was x. We don't know now what our hypotenuse is. So we got to make sure we remember that sine is opposite over adjacent, and cosine is adjacent over opposite, which you guys can write down here in your notes. So then we have tangent of theta is equal to opposite over adjacent, which, remember, in the unit circle we talked about was always y over x, right? Then, ladies and gentlemen, we have our reciprocal identities, all right? And remember, the reciprocal identities are these identities, but the reciprocals of them. So cosecant of theta is the reciprocal of sine. So what you could do is you could say cosecant is equal to 1 over sine of theta. It's the reciprocal of it. Or we can just simply write it as hypotenuse over opposite. All right? And we're going to talk a little bit more how these relate to each other in a second. But you can simply just take the reciprocal of it for cosecant. Secant is going to be the reciprocal of cosine. So if I said cosine of theta, that's just going to be hypotenuse over adjacent. And cotangent of theta is just going to be adjacent over opposite. Everybody follow me? Any last questions on that? All right. So that's all we simply need to do. So if we're looking at this, so that's going to be primarily what your 6 trigonometric functions are. So let's say I give you guys an angle. And let's say rather than writing, let's say I give you the adjacent now is 5, and I give you the opposite is 12. How can you find sine, cosine, tangent, cosecant, secant, and cotangent? Well, what's the only value you don't know? Hypotenuse. So how do we figure out what the hypotenuse is? Right, which is your Pythagorean theorem. So a squared plus b squared equals c squared, right? Hopefully you guys know this is already a triple, Pythagorean triple. So we could already know that this is going to be 25 plus 144 equals 169, which is the square root of 13. So c equals 13. So we already know that c equals 13. So if I actually gave you a problem on your homework, what you're going to have to do is figure out what all 3 of the sides are on your triangle, and then now just apply it. So we look at our angle, and if I said, what is the sine, just take what is your opposite over your hypotenuse? 12 over 13, right? What is your cosine? 5 over 13. All right, because now, ladies and gentlemen, if you guys notice, the difference between what we're doing now and what we did before is we don't have our point on the unit circle. It's not a coordinate point on that unit circle that we're talking about. Now it's just going to be relating with a triangle. So our tangent is going to be opposite over adjacent, which is going to be 12 over 15. Cosecant is going to be 13 over 12. Our secant is going to be 13 over 5. And the adjacent over opposite is going to be 5 over 12. And that's it. Done. Okay?